the next speaker.
Perfect. Thank you. Okay, so our keynote speaker is here. So let me just give you some brief introductory remarks. Some of you attended the first Planetary Defense Conference in Los Angeles in 2004. If you did, would you raise your hands, by the way? See, there are a few people around. That's good. And we only had 2 sponsors at that time, and maybe 140 people came. At that conference, science fiction author Larry Niven gave a keynote address and challenged us with the task of overcoming what he called the giggle factor that was preventing real progress towards planetary defense. The giggle factor, of course, basically at that time, if you said an asteroid is going to hit the planet, everybody would start to laugh at you and think you're crazy. So there's some crazy people around here now. Since that time, the community helped by the Chelyabinsk events, action of the United Nations supporting by the creation of 2 groups focused on planetary defense, and focused international efforts to discover and find ways to possibly deflect a potentially threatening object has made real progress towards that goal possible. In 2004, the question was asked, if an asteroid is discovered headed for Earth, what is the path to get that message to the President of the United States? At that time, there was no path. And so that has been fixed, and now there is. See, that's a good thing. By joining us today, our keynote speaker further demonstrates the progress that's been made in planetary defense over the last 15 years. We're honored to have Mr. James Bridenstine, Administrator of National Aeronautics and Space Administration, as our keynote speaker. Administrator Bridenstine served in the U.S. Congress for 5 years and became a NASA administrator in April of 2018. He was quoted as saying recently, and I quote, "We need to establish those stunning achievements that people remember, that are not tragic, but are in fact positive, and encourage the next generation to get involved in the STEM career field." I'm sure many of us here today resonate with that thought, share his vision to get the next generation involved in science, technology, engineering, and math, and would say, what better way to excite young minds than by challenging them to help us defend Earth from asteroids? I think that would be a truly stunning achievement for humanity. So with that, I'm pleased to introduce NASA Administrator Jim Bridenstine to give our keynote address. Thank you.
I don't know, is this a microphone for something? I'm not sure. Is it working? I don't know. All right. Well, number one, thank you for that great introduction. It's an honor to be here. I will tell you that one of the reasons I am here, the reason it's important for NASA to take this seriously is something you called the giggle factor. We have to make sure that people understand that this is not about Hollywood. It's not about movies. This is about ultimately protecting the only planet we know right now to host life, and that is the planet Earth. My second month in Congress, when I was in the US House of Representatives, second month, February 15th, 2013, there was a meteor that entered Earth's atmosphere. It entered over Russia, and it very quickly became a super bolide. It was about 20 meters in diameter. It was traveling at about 40,000 miles per hour, 60,000 plus kilometers per hour. And ultimately, it terminated over an area we call Chelyabinsk. To be clear, what is the super bolide? In this particular case, this object hit we'll just say it was brighter in the sky than the sun at that point when it entered Earth's atmosphere. And people could feel the heat from this object from 62 kilometers away. And the closer you were, the more intense the heat. And of course, when it eventually exploded 18 miles above the surface of Chelyabinsk in Russia, it had the same energy as, well, we'll say 30 times the energy of the atomic bomb at Hiroshima. 30 times that amount of energy. And of course, during the minutes that followed, a blast occurred, a blast that ultimately created a shockwave that damaged buildings in 6 cities. 7,200 different buildings had significant damage that had to be repaired. By the way, the temperature outside was sub-freezing, extremely cold. 1,500 people were injured badly enough to where they had to seek medical attention, over 1,500 people. And of course, panic ensued. These are significant events that happened on February 15th, 2013. I wish I could tell you that these events are exceptionally unique, but they are not. The modeling that we have done, that many in this room have done, and by the way, I understand the audience I'm speaking to. Everything I just said, you already know. That's why you're in this room. Who I am speaking to right now, we advertised that I was going to be here on Twitter and on Facebook. We invited people to attend, to watch online, and the NASA administrator is here to say that this event was not unique. In fact, it is an event that we model will occur about once every 60 years. And of course, in the last century, we've had 3 such events, one of which, by the way, let me just stop real quick. We talk about how this happened February 15th, 2013. That same day, there was another asteroid, not 20 meters in diameter, but 30 meters in diameter that came within 17,000 miles of the Earth. In other words, it was within the geostationary orbit belt of our asteroids. That same day, 30 meters wide, came within 17,000 miles of the Earth. It was 16 hours after the Chelyabinsk incident. Now, we're fortunate that that missed. It was detected. Chelyabinsk was not detected. Its radiant, of course, emanated from the sun, which made it very difficult to detect. But the Duende asteroid ultimately was detected. We knew that it was going to miss, and we have to do better. We have to make sure. Remember, 1,500 people sought medical attention. 7,200 buildings were damaged in 6 cities, and that was an asteroid that was 20 meters big. Here we have one within 17,000 miles of the Earth that, in fact, was 30 meters wide. That would have been a significant event. So the modeling says this is going to happen once every 60 years. The modeling also suggests that, in fact, the fact is that we've had 3 such events in the last 100 years. And of course, the Tunguska back in 1908, that particular event wiped out hundreds of square miles of forest over eastern Russia. So these events are not rare. They happen. And of course, it's up to us to make sure that we are characterizing, detecting and characterizing, tracking all of the near-Earth objects that are potentially could be a threat to the world. And that's what this international group is all about. And we are so proud that you're here and that this community attending the Planetary Defense Conference is helping us establish what the goals should be and what they currently are. In 2018, the White House published the National Near-Earth Object Preparedness Strategy and Action Plan. And from that, we have 5 very specific goals that we want to be able to achieve. Now, as we talk about this, there's another point of reference. We talk about the modeling, how often this is going to happen, what's happened in the last 100 years. Another point of reference is this, and NASA has proven this to be true. And of course, my friend Bill Nye also says it quite frequently, and that is this. We know for a fact that the dinosaurs did not have a space program. We know that to be true. But we do, and we need to use it. We have capabilities that exist today for astrophysics, NEOWISE, that we are using to detect, track, and characterize these near-Earth objects that could cross Earth's orbit around the sun. So we need to keep using these capabilities and technologies and make sure that we are prepared for the next generation of these events. A couple of things. I talked about the Chelyabinsk, 20 meters in diameter, just 20 meters in diameter. Right now, we are working by law, the United States of America, bipartisan support in Congress, signed by the president. It's gone through numerous administrations. We are working to detect, track, and characterize all of the objects, I should say 90% of the near Earth objects that are 140 meters or bigger. 140. Chelyabinsk was only 20 meters. We're talking about 140 meters. A lot of the folks in this room who have done modeling have said there's about 25,000 such objects. 25,000. Of those 25,000, we've been able to detect and catalog over 8,000 of them. Maybe 8,300 of them at this point. So we're only about a third of the way there. And the law that has been passed says that NASA is required to be able to detect, track, and characterize not just 1/3, but 90% of them, which means we have to use our systems, use our capabilities to ultimately get a lot more data, and we have to do it faster. So the number one goal that came from the National Near Earth Object Preparedness Strategy and Action Plan is to enhance NEO detection, characterization, and tracking. That's the number one goal. And we are working on that every day. One thing that I think is important for this group to understand is that this is a priority of the United States, and we want it to be a priority of the world. We want more international partners that can join us in this effort. We want more systems on the face of the earth that can detect and track these objects, and we want to be able to feed all of that data into one single integrated operating system so that ultimately we have the best, most accurate data that we can possibly get. Remember, 20 meters resulted in Chelyabinsk. What we're looking for is characterizing 90% of those that are 140 meters or bigger. What does that mean? 140 meters. That means it's big enough to destroy a state in the United States of America. And we've only been able to detect so far 1/3 of those objects. It's big enough for the folks here from Europe. It's big enough to destroy an entire European country. That's what 140 meters represents. Again, there's 25,000 of these objects we've only so far been able to detect, track, and characterize. In fact, characterization is a whole nother level, but detect and track maybe 1/3 of those. So we've got a lot of work to do there. The number two thing that we need to do is improve NEO modeling, prediction, and information integration. So we talk about modeling. The key here is ultimately not just detecting and tracking, but using computer modeling to know where that object is going to be 100 years from now. Where is it going to be 200 years from now? At what point will it cross Earth's orbit? And when it crosses Earth's orbit, will it ultimately come in contact with Earth? That's what we need to figure out with the modeling capabilities. We talked about the Duende object. The same day that Chelyabinsk made contact with Earth, we had this other object that was 30 meters wide that came within 17,200 miles of the Earth. 17,200 miles. Here's what we know based on the modeling. We have a pretty good guess that it's going to cross Earth's orbit again in the year 2123. Oh, well, 2123, that's a long way from now. Yeah, it is. It's, what is that, 104 years from now. 104 years. What we do today matters 104 years from now. I think that by the time that event comes, and by the way, it's not going to make impact. It will be close. It will be another one of those objects that comes close to the Earth, just like it did the first time. It won't make impact based on our current modeling. But I think we ought to be able to improve that modeling and ultimately create the capabilities necessary to prevent it from having an impact should it make impact. And between now and 104 years from now, I'm here to tell you that we in this room can do the things necessary to prevent that from being an issue. So we have to improve NEO modeling, prediction, and information integration. But when we talk about modeling, it's not just about modeling the orbits of these objects, these near-Earth objects. It's also about modeling the impact should one of them hit the Earth. Again, when we talk about, we're trying to get to a 90% capability for objects that are 140 meters or bigger. there's a whole lot more objects that are less than 140 meters large. And sometimes in these particular cases, we're not going to be able to have years of advance warning. In fact, it might be just a matter of days or months, depending on how small the object is. When you think about Chelyabinsk, for example. One of the things that we need to do is be able to model, if we have an event that is going to occur, we need to be able to model what that event is going to look like on the surface of the Earth. How much damage is it going to do? What is the damage going to look like? Ultimately, how are the people going to be impacted? And then, of course, we need to have the strategy to do the emergency preparedness and the reconstitution efforts that come from an event like that. Goal number 3 is developing technologies for near Earth orbit, deflection and disruption missions. So a lot of people in this room are familiar with Hayabusa, which is another great mission done by the Japanese Space Agency. And we are so thrilled that they are going to be bringing samples back to Earth. And a lot of people in this room are familiar with OSIRIS-REx, which is another mission at the asteroid Bennu. And it's going to be bringing samples back from that particular asteroid as well. So these are capabilities that we need to continue developing. The ability to do rendezvous and proximity operations in deep space with objects that are not cooperative in nature. And of course, Hayabusa and OSIRIS-REx are exactly those types of missions. And the ability to bring samples back to Earth to prove that capability, that technology, to help us better characterize these objects that may one day become a threat to Earth. So that's why we do those missions. It's one of the reasons. Yes, it's about science, it's about discovery, it's about exploration. But one of the reasons we do those missions is so that we can characterize those objects to protect, again, the only planet we know to host life. People ask me as the NASA administrator, what's your favorite planet? Earth. Are there any questions about that? Okay. So number 4, we want to increase international cooperation and NEO preparation. International cooperation, many in this room are from all over the world. We need more partners from all over the world. When we talk about the International Asteroid Warning Network, IWAN, currently we have 15 entities that are involved in this. We need more. We need every nation on the Earth that is interested in preserving this planet to be involved in these activities. Every nation that is capable, I should say. And then we talk about the Space Mission Planning and Advisory Group, a spin-off from UN COPE-US. We currently have 18 space-capable nations that are participating in that activity. I would assess that we need more. We want more participation from the entire world to ultimately be able to prepare our planet for such an event. And then, of course, a lot of people here are familiar with the double asteroid redirect test. This is a capability that I think is important for us to understand. If we were to impact with double asteroid, we're talking about a small asteroid that is in orbit around a bigger asteroid. If we were to impact the small asteroid, how will it affect the trajectory of the system? This is another important capability that NASA is developing. And we've been developing for a long time, but we're very excited about getting this launched and ultimately testing it against what we predict will happen. And this is going to help us better characterize in the future if we had some kind of crossing event with an asteroid, how would we change its trajectory so that ultimately it does not affect our own planet. The last thing, goal number 5, is to strengthen and routinely exercise near-Earth object impact emergency procedures. So tabletop exercises, which this group does. And now we're going to have, 4 different tabletop exercises from which we can have an international consortium of people kind of helping us understand how do we deal with the events that could occur in the future. We need to go beyond simple tabletop exercises. We need to expand them. We need to, no kidding, do real exercises so that ultimately we are as prepared as possible should one of these events occur. In closing, I just want to say this conference is very unique. It brings together astronomers, aerospace engineers, mission designers, emergency response planners, communications experts, and policymakers from all over the world. The interdisciplinary and collaborative work undertaken by this community has but one goal: save the planet from cosmic disaster. No pressure. There is no conference like this on the earth. I commend your efforts to date and support you to redouble our already deep commitment to this goal. Last thing is this, and this is important. Many in this room are familiar with the fact that the United States has a new space policy directive from the president. That space policy directive is to go to the moon, to go sustainably, to take advantage of commercial partnerships that historically did not exist, but to get there using the biggest, most powerful rocket that ever existed. We call it the Space Launch System, with an exploration upper stage. When we talk about the Space Launch System and its capability, yes, it's about going to the moon sustainably. We want to go to the moon and stay. And by the way, we want all of your nations to participate in this activity with us. We want to go to the moon, this time sustainably. When we go, we're going to stay. With commercial partners and international partners, we want to utilize the resources of the moon, and then we want to take all of that capability, that technology, retire the risk, and go to Mars. And under the direction of the president, the vice president announced just about a month ago that when we go, we're going to land the first female on the south pole of the moon in the year 2024. So NASA is highly committed to this effort. The only way to achieve that is to use this rocket, the biggest rocket that has ever been developed, the Space Launch System and the exploration upper stage, in order to get humans to the surface of the moon in 2024. Why does this matter? Because this rocket is an enabler for what you in this room are trying to achieve, which is the protection of planet Earth. Think about this for just a second. When we talk about launching a mission to Europa, a moon of Jupiter, a water world, complete ice shell, liquid water on the inside, we're now looking at geysers coming out of Europa. We want to go to Europa to discover life on another world. That's why we want to go to Europa. If we were to launch on a commercially available rocket today, it would take over 7 years to get to Europa. If we were to launch on SLS, which is a rocket being built for moon activities or Mars activities, if we launch on SLS to get to Europa, it's about 3.5 years. That's a major enabler. It's why we need a capability like that to be produced, not just in the United States, but we need capability like this produced for the planet, so that ultimately, when discoveries are made and risk needs to be mitigated, we have more options than we would otherwise have, which is why SLS is so important. So I'm going to take just a few minutes here, and I'm going to play a video about what NASA's goals and intentions are. Know this, that these goals, intentions, capabilities affect you in this room. They are available to you in this room in the future should an event arise. So this is not just about going to the moon for science, exploration, discovery, but having a line of rockets capable of going deeper into the solar system than ever before is an important capability for the world. So I'd like to play just this quick video. It's about 3 minutes long about what NASA is up to.
Ignition sequence start. All engines are running.
We have taken tremendous steps.
We choose to go to the moon before this decade is out.
We have achieved the earth-shaking, the breathtaking, the groundbreaking,
One small step for man.
and left a mark in the heavens. Our successes build one upon another to amplify what is possible. It's time we take the next great leap. We're building the next chapter of American exploration, returning to the moon to stay, so we can go beyond to Mars, to expand what's possible and further our understanding. The architecture for these missions is already taking shape. We will go with new systems, bold designs, and a sustainable mission. can hear it, taste it, touch it. We are going. We are training, testing, pressing our pioneering spirit into every component, defining our resolve with every line of code, and securing our success with every welcomed partnership. This is not hypothetical. This is not about flags and footprints. This is about sustainable science and feeding forward the advance of the human spirit. Because we are the pioneers, the star sailors, the thinkers, the visionaries, the doers. And because we stand on the shoulders of giants to go farther than humanity has ever been, we will add our names to the rolls of the greatest adventurers in history. Every day, every mission, we advance this cause. We are NASA. And after 60 years, we're just getting started.
So it might be true there's not a lot in that video about asteroids, but it is also true that the capabilities that NASA develops ultimately have the ability to serve our world in a way that you in this room know is so important. So I'm happy to answer a few questions. Okay, about 5 minutes. Okay, sounds good. I guess we've got a microphone here. We'll go ahead. Yeah. I've got a microphone here. I'll repeat the question.
Good morning, Jim. Thank you for coming. I'm Professor Dindal from MIT. I have a question. I want to address your first objective, which is the detection of near-Earth objects. And NASA has ready something called NeoCam, which I am not a part of. I'm a non
Got it.
But that project is ready. It's been competitively reviewed, technically reviewed. It's ready to go. And I would encourage you to ask your friends, Thomas Zurbuchen and Lori Glaze, and ask them to see what can we do to make that happen. Because I believe that because we now have the technical capability to know what's out there and what's coming our way, we have a moral obligation to do the task. Thank you.
That's a great question. So for those who didn't hear, what he talked about was NeoCam and the idea that ultimately we need to be able to have space-based capability to detect, track, and characterize these objects that could pose a threat to the Earth. And so you make a great point. NeoCam is on the agenda to achieve that. I will say that right now, if you look at what we use from a space-based capabilities perspective, we have NEOWISE, which is a near-Earth object wide-field infrared explorer. NEOWISE, just to be clear, was an astrophysics mission. It was designed specifically to help us understand galaxies and stars and planets in our solar system. That's what NEOWISE is. It was never designed to ultimately detect, track, and characterize the objects that could be a threat to the Earth. However, after it came to the end of its mission, it got turned off for a period of time and then turned back on. And because of that, we're now being able to characterize a lot of objects that before we couldn't. So the point is this. The space-based capability that we have right now is, in essence, a retread from astrophysics missions of the past. And we need, as you have identified, specific capability that is designed for this mission, which right now in space we are lacking. So I will certainly talk to Thomas Zurbuchen and Lori Glaze, and we will have a conversation about ultimately how to get that funded and fielded. But know this, we are committed to doing that. Thank you for the question. Hi there.
Hi, Jan Osborg with the RAND Corporation. I have a question. In your interactions with, heads of other space agencies, the political world, hopefully when the topic of planetary defense comes up, there's no giggle factor anymore.
No,
But-
you're right. Go ahead. I'm sorry.
But what is do you see a need for actual, factual information, additional information? Since I guess a lot of, folks who should care about it don't read, the scientific papers that
Right.
go with it.
So, you're exactly right. The giggle factor is for maybe some folks that don't read the scientific papers, that aren't familiar with the history, that aren't looking at the events of the past. That being said, I will tell you when I meet with the heads of space agencies from all over the world, and it doesn't matter. So I talked with Jan Werner, the European Space Agency, very committed, more committed than probably anybody that I've met on this particular topic. And of course, he's been leading on this for a long period of time. You go to the JAXA, the Japanese Space Agency. Again, they've got the Hayabusa mission, so they're committed to being able to characterize these asteroids in deep space. When we launched Nick Hague the first time in an attempt to get him to the International Space Station, which was a failure, on a Russian Soyuz rocket, he came home safely, just so in case anybody is not aware, he came home safely because of the ejection capability of the Russian Soyuz rocket. But when I was over in Russia, the head of Roscosmos, Dmitry Rogozin, that was high on his agenda. As you can imagine, with Chelyabinsk and Tunguska, Russia has been significantly impacted by these events. So they have a keen awareness and an intensity on this that I think is important. So when you meet with the heads of space agencies all over the world, they understand the importance here. I think when you talk about it with the general public who might not be reading those scientific papers that you reference, they think it's Hollywood. They think it's movies. And yes, there have been movies made about it, but what we're doing is very serious. This is.
What about the layer in between? Not the technical people, not the general population, but the politicians, senior decision makers.
So from my experience, in fact, I was testifying before the Senate Commerce Committee not too long ago, and the NeoCam issue came up. So it's on their agenda, I can tell you that. I will also say that the reason we are characterizing 90% of the objects in Earth orbit that are, or I should say in the sun's orbit that are 140 meters or bigger, the reason we're doing that is because of a law passed by Congress in 1998, bipartisan, signed by the president. So this has had strong bipartisan support. I think the political establishment understands it, at least better than probably the general public. But I think the general public is becoming more aware. It's one of the reasons that I'm here and we are live streaming this event.
Thank you, sir.
Yep.
Hi, Jim. First, I want to thank you for coming up here and speaking. I think in all my years involved with this, and I was at the first Planetary Defense Conference, we have never seen a NASA administrator be able to talk about this subject in such detail, and I think that's great. So thank you very much for coming. But I do want to ask you a tough question. I'm a proud ex-NASA employee, former astronaut, and
just a minor employee, an astronaut.
Well, one of many. But and this is an incredibly exciting time for NASA. We've got what appears to be, from the outside at least, support to do some very, very big things.
Yes.
And how do we prevent what has happened in the past? And we know we haven't had a great track record with completing all the things that we start, right? We started and stopped on quite a number of programs over the years. How do we make it different this time? How do we gather the resources and stay on a course long enough to complete that course before we switch again?
That's a great question. A couple of things. when we talk about risk to these kind of programs, what he's referencing is a couple of things. Number one, you go back to the Space Exploration Initiative in the 1990s. It was a return to the moon and then on to Mars. And then you go to the vision for space exploration, started in 2004, I believe, but that was a return to the moon and then on to Mars. And here we are again. And in each case, priorities changed, budgets never materialized, and we never achieved the end state that we were after. In this particular case, we now have another president who is saying we need to go to the moon. What's interesting here is that when the president now says we're going to go to the moon, he gives it a date, and that date happens to be 2024 at a time when the president could still be in office. So the point is this: when you talk about the risk to these programs, there's two risks. One is the political risk. Two is the technical risk. I have no doubt that NASA can retire all of the technical risk necessary to achieve the end state of the first woman on the South Pole of the moon in 2024. NASA can achieve that. The first thing that we have to retire, though, is the political risk, which is how do the budgets materialize? How do we get the resources to accomplish the end state? In the past, there have been attempts to cut certain parts of NASA to fund the program. And that creates parochial challenges. If you go back to saying, hey, we're gonna cut this particular program, and of course, as an astronaut, you're familiar with how important the International Space Station is to the commercialization of low Earth orbit. So that's underway right now. There are some people in Congress who would say that we need to cut the International Space Station in order to get to the moon. That's a non-starter. Why? Because you lose Texas, you lose Florida, you lose Alabama, and it's bipartisan opposition to such an event. So we can't allow that, in my view, to happen. The second thing is, well, it's been tried in the past that we can cut resources from the Science Mission Directorate in order to achieve that end state. That creates a whole different level of challenges. You lose Maryland, you lose California, it becomes a partisan fight. So that's not a good position to be in either. So to retire the political risk, we have to come to the realization that these things have been tried in the past, they don't work. So what are we going to do different this time? We can't do the same thing over and over again and expect a different result. So my goal, and it has been the goal the whole time, is to keep a strong bipartisan, support, which NASA has had and we continue to have. We want to keep that strong bipartisan support, and we don't want to turn this into a parochial fight. And if we can achieve that, then ultimately we can have the end state achieved. So I think those are important things to remember. It's also important to remember that Congress has given us the NASA Transition Authorization Act, which makes sure that we have the same programs and policies in place from one administration to the next. Our president has been very keen on making sure that we don't undercut the progress of the programs that are necessary to accomplish the end states that all of us want to be able to achieve. So it's a great question. It's a question that I get everywhere I go. So that shows you how much it's on the mind of the people who work at NASA. Can we do one more question? I'll be quick. I know there's a gentleman standing in line here.
I'm Jeff Placia from APL. I wanted to point out that in 2029, on Friday the 13th in April, the asteroid Apophos is going to come by the Earth at an altitude less than geosynchronous orbit. And this object is, hundreds of meters in diameter, and it presents a unique opportunity to go to an asteroid and conduct a mission and see what it's made of and how it responds to the Earth's tidal force. And that might be something that NASA could do outside of the normal Discovery New Frontiers solicitations as sort of a planetary defense mission, perhaps directed or not.
Awesome. That's a great point, and I will certainly take that on board. So I appreciate you bringing that up. And by the way, it's important you bring that up because we're streaming this and people need to hear that. So, all right. Thank you all so much for having me. It's an honor to be here.
Thank you. Yeah, I guess to put this back here. Huh?